Hello and welcome to this video about the principles of DevOps and how they impact the process of developing software. Let's begin. Software development, as it sounds already, is the development of software, which means there are people called developers whose job it is to develop software. The entire process involved in building the software is sometimes referred to as SDLC, which means Software Development Lifecycle. It is very important not to confuse these with DevOps. DevOps, on the other hand, has a set of principles that focuses more on releasing quality software to its end users in a speedy and reliable manner. In the previous video, we learned about DevOps and its evolution till today. You already know that DevOps is a set of practices and principles that aim to close the gap between development and operations teams so that software can be delivered faster and more reliably. It's a change in culture that focuses on working together, automating tasks, and always getting better so that customers get more value faster. In this video, we will focus more on those DevOps principles. Before we delve into those principles, let's spend a bit of time to understand the differences between SDLC and DevOps. SDLC and DevOps are different concepts. They do not replace each other, nor do they compete. In fact, they complement each other perfectly. While SDLC is the entire workflow and processes involved in producing software from given requirement, DevOps is the culture embraced by engineering teams to follow certain principles and practices with the aim to release software fast and reliably. Similar to how the Keep It Simple, Stupid KISS principle guides software engineers' decision while developing software, DevOps principles act as a point of reference for a DevOps team. Without these guiding principles, the many technological and operational sides of DevOps could easily become convoluted without direction. DevOps principles, or lifecycle as also referred to, is defined as a combination of different phases of continuous software development, integration, testing, deployment, and monitoring. Different organizations have over the years tweaked varying principles that they believe works for them as they adopt DevOps. For example, Microsoft, one of the leaders in the DevOps ecosystem, describes the DevOps principles as capabilities. Some people refer to these principles as the DevOps lifecycle. The capabilities identified by Microsoft are continuous planning, continuous integration, continuous delivery, continuous operations, continuous security, continuous quality, continuous improvement, and continuous collaboration. One thing that you may already know about DevOps is the fact that there are many tools that engineers learn and become skillful at. These tools are the drivers of each of the principles. At every phase in the development lifecycle, a tool may be required to fulfill a particular principle. For example, Jira is a planning tool that is popularly used for continuous planning. Amongst all the different principles, there are a few that must be considered for successful DevOps adoption. These are automation, communication and collaboration, continuous integration, continuous delivery, continuous deployment, continuous testing, continuous monitoring, continuous learning, and feedback. Let's explore each of them briefly. And by the way, if you don't quite understand them fully just yet, do not worry. As you progress in this DevOps journey with Dare.io, they will become much clearer. Automation. Automation is one of the foundational principles of DevOps. Testing and deployment are examples of repetitive operations that can be automated to increase efficiency and lower mistake rates. Scripts can be developed in programming languages such as Python or Bash to drive automation. Communication and collaboration. Effective DevOps requires a strong culture of communication and collaboration. This indicates that all teams are pursuing the same objectives and that everyone is aware of any potential problems or roadblocks. Imagine having smooth collaboration amongst your teams on Slack or Microsoft Teams. Continuous integration. This is a practice where developers regularly merge their code changes into a central repository so that automation can be triggered for building and testing the code continuously. Examples of tools that drive this principle are Jenkins, GitLab CI, GitHub Actions, Drone CI, Travis CI, and a few others. Continuous delivery. This principle builds on top of continuous integration discussed earlier and focuses on automating the build and test, just as continuous integration does, but goes further to stage the code so that it waits for a final and manual decision of an engineer to release the code to a production server where the customers will be able to use it. The same tools used at the continuous integration phase can also be used here as well. Continuous deployment. This principle helps development teams to cut down on the time it takes to get code into production. It is exactly what continuous delivery does, as long as there is no failure during the build and testing phases in the pipeline. When you see CI/CD, the CD part usually refers to either continuous delivery or deployment. For tools, the same tools used for CI can also be used for this part of the CD as well. Jenkins, GitLab CI, GitHub Actions, Drone CI, Travis CI, etc. Continuous testing. This principle helps teams run automated test cases often. This improves quality because problems are fixed as soon as they are found. It also helps development teams find operational problems faster. So, continuous testing brings developers and operations closer together. Examples of tools that drive this principle are Selenium, Gatling, Appium, Apache, JMeter, and a few others. Continuous monitoring. Teams may more rapidly detect and address problems and enhance the overall quality of their software by closely monitoring and measuring the performance and usage of their systems. Tools like Grafana and Prometheus are great examples. Continuous learning and feedback. The DevOps process is iterative and ongoing. Teams should continually be making changes to how they work and learning from their past mistakes. To conclude on the learnings from this video, you should also be aware of the CAMS model, which was developed in 2010 by Damon Edwards and John Willis to highlight the fundamental principles of DevOps. CAMS stands for culture, automation, measurement, and sharing, and also buttresses everything we have discussed. We learned a lot about DevOps principles and their impacts on software development in this video. In the next video, we'll talk about the great benefits that companies enjoy from adopting a DevOps culture. I hope that you got a lot out of this video and has shaped your understanding even more. Let's keep moving, and I'll see you in the next video.